Emerton's law, and also known as Gay-Lussac's law, is as follows. The pressure exerted by a gas at constant volume and number of moles is directly proportional to its absolute temperature on the Kelvin scale. So we're basically saying pressure is proportional to temperature at constant N and V for volume. Meaning basically that P over T is equal to some constant. So therefore Emerton's taught law is basically P1 over T1 is equal to P2 over T2. Realizing that temperature must be in Kelvin, and we're talking about constant number of moles in volume. Let's try a problem. An aerosol can has a pressure of 1.4 atmospheres at 25 degrees C. What pressure would it attain at 1200 degrees C, assuming the volume remained constant? We assume constant number of moles of gas since there is no evidence of gas escaping. Since we are at a constant volume, it allows us to use Emerton's law. We know that temperature and pressure are at a given volume and a new temperature later on, so we can easily solve for the new pressure. We'll call 1.4 atmospheres pressure 1. We'll call 25 degrees C temperature 1, which we have to convert to Kelvin, 298 Kelvin. And we'll call 1200 degrees C temperature 2, which we will also have to convert to Kelvin, 1473 Kelvin. So we know P1 over T1 is equal to P2 over T2. We have to rearrange and solve for P2 and also use Kelvin temperatures. So I get P2 is equal to P1 times T2 divided by T1. Plugging our values, we said P1 would be 1.4 atmospheres, T2 1473 Kelvin, and T1 298 Kelvin. Kelvins cancel, leaving us in our atmospheres, which is 6.9 atmospheres. A couple of notes, must use Kelvin temperature. And then we also know since the temperature increased, we know that the pressure will also increase because they're a linear relationship. So we anticipate the pressure to increase, and it does. It goes from 1.4 atmospheres to 6.9 atmospheres, while the temperature increased from 25 degrees C to 1200 degrees C. Homework 40.